I request everybody to be please seated. We'll start our session in few minutes. Good afternoon, everyone. I hope you had a delightful lunch and a chance to connect with the fellow mates. We now return for a very special segment of the day, two distinguished talks by eminent experts in the field. It is my pleasure to invite you all to join us as we begin this special session. It is my great honor to welcome Dr. 𝗘𝗃𝗃𝗺𝗍𝗍, Professor at IIT Madras, as our plenary chair for this session.
Thank you. Good afternoon. So for this session we'll have two talks, one by Professor 𝗘𝗏𝗃𝗃 and one by Professor Novak. So first will be by Professor 𝗘𝗃𝗃𝗃. He's a senior faculty member in the Department of Civil Engineering in IIT Bombay, a very nationally recognized expert in structural engineering, seismic safety, disaster risk management. With over 30 years of experience, he has been instrumental in shaping earthquake resistant design guidelines and contributes to national standards through the Bureau of Indian Standards. He has advised several key government bodies including Maharashtra State Disaster Management Authority and the Ministry of Road Transport and Highways. His expertise has directly influenced urban resilience policies across India, and a contributor to the World Bank's primer on climate resilient cities. Professor Sinha continues to be a leading voice in advancing climate adaptive infrastructure and risk informed development. I also had while applying for DST funding, which you will all know, he is a very common figure in in the PAC Program Activities Committee. So please join me in welcoming Professor 𝗘𝗏𝗃𝗃 for a talk.
Knox team, please change the screen.
It's 2:15 now.
Yeah, I'll finish in. Thank you. So first of all, thank you, Professor Pillai, for making me feel really old. I like to feel that I'm young at heart and would like to leave it like that. But thank you again for the very kind words, and to everybody who heard of it for the first time, please don't believe even half of what he said. He was just being very polite. So first of all, I must say that I'm delighted to be here to get a chance to talk in front of you on a topic which is going to be slightly different in the flavor in which we are going to discuss, and really I'm grateful to the organizers for giving the chance to be over here with you and to share some of my thoughts. And what I'm going to talk to you is not the structural engineering of today, not the structural engineering of tomorrow, but the structural engineering of day after tomorrow. And the reason why I say day after tomorrow is because we already have a roadmap of what structural engineering is going to be, say, in the next 10 years. And I can tell you that the way in which the structural engineering profession is going to transform would not be sufficient to cater to the needs of the society. And that is why it has to transform further, which is what I'm going to talk about, which is focus on resilience. I don't know how many of you are familiar with resilience in the context of structural engineering. Everybody talks about resilience in terms of society, like how resilient a particular society is and so on. What does structural engineering, what do the equations, equilibrium equations have to do with resilience? So let us just dwell on that. First of all, why do we talk about resilience in society is to capture the ability of the society to respond to unfavorable events. And the concept of responding to unfavorable events is known as disaster risk management. And the unfavorable events themselves are known as disaster risks. So, disaster, for those of us who work in the field of disaster management or disaster risk management, we categorize the disasters in 4 different baskets, what we call as the known known, the known unknown, the unknown known, and the unknown unknown. So the known knowns are the one where both the cause of a disaster and the likely consequences are known, so they can be predicted in the future. The known unknowns are where the causes are known, but it's very difficult to predict the consequences. So for example, earthquake disasters. We know all the areas which are prone to large earthquakes, but to be able to predict what will be the consequences is an extremely difficult task. The third is the unknown known, where the causes may not be known, but it is possible today to be able to predict the consequences. A good example is the pandemic. We don't need to know the cause, the exact pathogens which are going to cause, but depending on whether it is airborne, waterborne, whether it is it affects which part of the body, it is possible to predict the consequences, so it becomes the unknown known. And the reason why we focus on these 3, the known knowns, the known unknowns, the unknown knowns, is that we want to actually develop the capacity for the humanity to survive against the unknown unknowns. A large meteor striking the earth, or something else which is totally unthought of. So it's so unfathomable that we cannot even begin to imagine what the causes are going to be. A nuclear holocaust, for example. So how does the society come out of that with its system intact? That is the disaster management of the unknown unknowns. So these are not concepts for the sake of concepts. These are not concepts to be worried about by the politicians or by the social leaders. These are things which have an implication in the profession of structural engineering also. So there are things about which the structural engineer should be aware so that they can play their role in it. Now specifically when it comes to disasters, we worry too much about earthquakes is a common refrain, that everywhere we go when people talk about disaster it's earthquake, earthquake, earthquake. And there is a reason for it. In the 20th century, nearly 60% of all the deaths which occurred due to natural disasters were because of a single cause of earthquake. 60% of the total deaths. Even if you look at the recent past, from the time when globally concerted programs on disaster risk management started, which is from the early 1990s onwards, even now the data is very sobering, that more than 50% of the deaths continue to be caused because of earthquakes. So if we don't solve earthquake problem because we feel that this is one of the problem compared to everything else, then we will continue to have this staggering death figure. So if you want to save lives, and if you want to have a structural engineering contribution to save lives, then we have to recognize that most of the deaths will occur due to earthquakes, and that is where most of the attention has to be. And incidentally, the total number of deaths, it seems that they are coming down, but even that is not true. What is being found by the data is that the decadal number of casualties due to disasters are actually increasing. So as we know, every decade the human population is more than the previous decade. So if the rate of deaths are remaining constant, then the number of deaths will increase every decade. But actually, the number of deaths are increasing at a faster rate than the increase in population. And what it means is that in spite of so much talk about disaster management all over the world, including in countries like India, actually so far it is a losing battle. That we are doing a lot, or we feel that we are doing a lot, and maybe there are many people who would have died whom we are able to save. But we are not even able to reduce the rate of fatalities. Even that remains constant. And why is it important for us? Because as most of you would be knowing, earthquakes don't kill, collapsing buildings kill. So it's because of the structural engineering lack of performance that the death toll in earthquakes are so large, and again it is because of the lack of performance of structural engineers that the death tolls are increasing in spite of all the other advancements which are happening in society. And it is not just the death which is the problem. The loss of infrastructure is staggeringly high. So after every major earthquakes, the backbone of the economy of the region gets very, very badly damaged, and it takes decades and decades for that area to recover. And that also is the problem, because the people of that area get into perpetual poverty because of this reason. Economic losses are also increasing. So overall the gains due to disaster risk reduction are plateauing, and because of that disaster risk reduction needs to be rebooted, and it has to reboot by going to the root cause of the problem, and that is collapsing building, collapsing infrastructure. So if our buildings don't collapse, and if our bridges and roads and rail networks continue to function immediately after a disaster, then we can cope with the other consequences. So it's ultimately structural engineers who have to be at the forefront of disaster risk reduction. And don't think that the society is going to come and ask you that be at the forefront. Don't think that the political leadership is going to come and ask you to be at the forefront. You have to understand that you have a role in society, and your role in society is to leave it better than when you started your career, and you have to force yourself and make that happen. So if you are not a champion of better world in terms of disaster risk, then in that case nobody else will come and ask you, because if they knew that you were the champion, they would not even allow you to sit in a meeting like this. They would be clamoring that please come and try to help us. The whole reason that why we are able to talk is because they don't even believe that this is a problem where you have the solution, even though you alone have most of the solution. So understanding disasters, understanding disaster risk, understanding the role of structural engineers, if nobody else will be able to do that as well as the civil engineering community. So it's a civil engineering community which has to understand and which has to go and convince the others that allow us to do what we alone can do, which is to make you safer. So that is the message. Now how do we do it is what I'm going to talk about. So it's not just that you are charged in doing something. The question also is, okay, you are charged, so what can you do? So as you know, the earthquakes are also what we are talking about. The earthquake is the most catastrophic natural disaster known to mankind. And what are the kinds of consequences? The collapse of structures, which of course lead to casualty, loss of reoccupancy and functionality in structures which don't collapse but are damaged, and consequent economic losses, consequent household displacements, consequent business and economic disruption. Then there are social losses, including community losses, because entire communities are uprooted and moved somewhere else after a disaster. And there are many, many other indirect adverse consequences which occur. So overall, earthquakes pose an unacceptably high risk to the society. And as I mentioned, that more than 50% of the casualties during last few decades have been because of earthquakes, and specifically because of collapsing structures. And as I also just said, the engineers can have an important role to reduce the casualties. Now, what is the present status? That we have design codes, whether it is for buildings, bridges, tanks, for all kinds of structures we have design codes. And the present design codes, which are mainly prescriptive, they aim to protect lives. The tomorrow's design code, but I said that we are going to focus on day after tomorrow, because tomorrow we already know, tomorrow's design codes are going to be performance-based design codes. And they will consider not just life safety like the current codes, but also look at what is going to be the kind of immediate damage and what is going to be the kind of economic losses, and also provide means to control them. So in addition to controlling the loss of life, you would also be able to control through performance-based design the extent of immediate losses and also the extent of immediate damage. But they would have no clue about what the recovery is going to be from the earthquake. And remember, our ultimate objective is for the society to recover, and if the society is to recover, then the infrastructure has to recover. So tomorrow's codes are also not going to talk about recovery. So repairability and recovery are not going to be explicitly considered even in performance-based design. So that remains the day after tomorrow's specification. And why is it required? Is because widespread functionality losses and extended delay in reoccupancy of buildings, they exacerbate the indirect losses and disrupt the normal functioning of society. Then understanding the system vulnerability is not just a facility, but the system vulnerability that lead to the downtime in post-earthquake phase is required for planning disaster risk reduction. I may have, let us say, a network of health facilities, hospitals in an area. Then how can I ensure that my system works even if some hospitals are disrupted? So that requires a system approach, because I cannot make every facility safe. And recovery assessment is a critical step in developing and implementing the resilience strategies. So let me give you an example from 2011 Christchurch earthquake in New Zealand. The earthquake was not large and very few buildings collapsed. The loss of life was 185, very, very low, which means that the courts did their work, that the loss of life was minimized. But what also happened was that many of the buildings could not be reoccupied, and more than 65 to 70% of the buildings were eventually demolished. So this shows the, okay, I have to get a hang of it. This shows the downtown area, and the blue area in between shows the area where the none of the buildings were allowed to be reoccupied because of the damage to the buildings. Aftershocks were still continuing, and that entire area had to be vacated. Now this is, I'm showing on the left hand side the graph of what is the percentage of downtown area which was allowed to be reoccupied from the number of months after the earthquake occurred. And you can see that even 2 years after the earthquake has occurred, the number of buildings which are allowed to be reoccupied is not 100%. So it takes that long for the recovery to occur. And if you look at the data in aggregate term, the human casualties were only 185, just 185 deaths for the earthquake that size, and about 7,000 injuries. But the economic loss was 40 billion New Zealand dollar, which was 10% of national GDP. Now those of you who read newspapers would see this debate happening in India all the time. Is our growth rate going to be 6.3% or 6.4%? So 0.1% of GDP is a hugely important number. 0.1% of the GDP is a hugely important number on which government officers and analysts and bankers, they spent long time arguing with one another. So it's that important a number, 0.1% of GDP. Here, at an instant, just like that, 10% of the GDP lost. So economic impact, you can imagine how staggering it was. And New Zealand as a developed country was very well insured, and the total payout of the insurance industry was about 21 billion New Zealand dollar, which if they have to recover back from insurance premium at the same rate which was being charged before the earthquake, would take them 40 years to recoup the losses, which obviously also means that the insurance premium would increase by many times, not many percent, many times after the earthquake, just so that the insurance companies can come out of bankruptcy. And all this happened when the number of deaths were only 185. So if somebody thinks that 185 death means that the courts worked well, just look at all these other things. The insurance companies had to pay out, so they needed the money. So all the investments which they had in stocks and bonds, they had to start selling off. The stock market crashed over there. If the stock market crashed, all the companies which are listed, their value crashed. So their income then became less, or their value became less than the salaries which they had to pay. Large number of people had to be fired by the companies, not because their products were not doing well in market, but because they didn't have sufficient capital to run the company. So all kinds of really adverse impacts happened, even though the death tolls were so low. So how can we get around it? And the way we can do it is by focusing on resilience instead of life safety and performance. So resilience has already been highlighted in several international frameworks. Unfortunately, most of these frameworks are not read by structural engineers. So two of the major frameworks are, first of all, the Sustainable Development Goals of the United Nations. So I'm just in red mentioning where all they have stated as an objective of having resilience, and you can see that it is coming at many places. And secondly is the Sendai Framework for Disaster Risk Reduction. So there also at many places they are highlighting the importance of resilience. So major international cooperations or major international frameworks are already highlighting the importance of resilience. So it is not that some professor somewhere is standing. I'm just explaining in greater detail what these international and these international frameworks are agreed by more than 190 countries, including India. So I'm already saying, all that I'm doing is saying what these are, I've already agreed, including our leaders. So what is resilience? So if you have, let's say, an earthquake, then before the earthquake the functionality is 100%, and then there is a drop in functionality because of the earthquake, and that happens because there is structural damage and non-structural damage. And then after the earthquake, the recovery process will start. Initially, nothing will happen because people are trying to save lives and all. That is the focus, and also to raise funds and so on. And then the recovery will start, and after a certain time, which is known as the recovery time, then there would be hopefully 100% recovery. So this is the track which happens if we design the buildings as per the current code and the next generation of code. What we want is that the initial losses should be lower and also the recovery should be faster. So, sorry. So from the bottom line, yeah, I know. From bottom line, we want to go to the top line, which I call as the code to resilience gap. So this is what our objective is. And if you look at what has to be done after an earthquake, there are many steps which are required. And these are the steps to be controlled in order to achieve resilience. So if I look at the pathways, or if I look at the steps in a flowchart fashion, then after an earthquake, we need to have engineering measures and management measures. Engineering measures would be things like structural improvement, we make the structure stronger, and the non-structural performance improvement, so the performance-based design. So these two we do, we can reduce the extent to which there is a decrease in performance. And then there is a whole lot of management measures. We can try to eliminate the post-disaster delays, we can try to reduce the, we can eliminate post-disaster delays as well as reduce post-disaster delays depending on the action we are talking about. And both of them can have a number of associated action where we can do. Now, this is just showing some set of the actions. Now, if the structural design is somehow able to anticipate and address these, then only we have the tools in our hand to enhance resilience. And if you look at these tasks, none of these tasks are given in Indian standards or any other design standards. And if you think about a typical structural design firm, none of these are being done by a structural design firm. So what it means is that structural engineering, the way the profession is currently configured, would not be able to deliver resilience. So even the profession has to adapt on how to ensure that resilience is going to be delivered, and different countries will find different ways of doing it, but already so many people are worried about it that we will reach that stage. So this is the focus to improve resilience. So how do we go about doing it? Quickly, in a minute or so, I will show you. So for a typical building, so we have chosen a reinforced concrete building in Delhi, a typical building complying with IS code, and then there is a series of steps through which we have done the analysis to find out what is the performance of this typical commercial building in Delhi, not just at the code level earthquake, but for even much stronger earthquake. And stronger means with a more rare or with a longer return period. So what is the kind of behavior which the building is going to exhibit? So a number of steps are required. The damage and loss has to be assessed, including repair cost and repair time. Then reoccupancy and functionality loss and recovery, they have to be assessed. And already there are methods for doing this which the structural engineer can apply. And all these things have to be done in a highly uncertain framework. The earthquake shaking itself may have uncertainty, the material properties, steel and concrete, would have uncertainty. So at least in this study, for each of the structural configurations, we were doing 10,000 Monte Carlo simulation to be able to portray the impact of uncertainties in various parameters. And so this is the plan of the building I'm showing. So one of typical frame was taken, and we had considered buildings of various heights from 2-story to 12-story. And these are just some of the results. So if you look at the structural performance, which is what the code is giving today, then we find that the collapse and irreparable residual drift, they are stable up to the maximum considered earthquake, which is incidentally what the code assumes that it is delivering, and we find that the code is correctly delivering. But we are finding that the likelihood of irreparability is very high. So just because it's damaged doesn't mean that it can be repaired. And also we are finding that the collapse and the IRD, the irreparable residual drift, the potential is very high, and it shows a decreasing trend when the building height is increased. So what happens is, as the building becomes taller, the gravity load becomes more proportional or more predominant in the overall loading, and that has an effect of improving the performance of the building, which is also contrary to what is often assumed. But if you look at the performance including the non-structural component, then we are finding that the economic losses rise very rapidly after the design basis earthquake, and repairs are very expensive even at maximum considered earthquake. So repair is not going to cost 5 to 10% of the replacement cost. It's always well in excess of 20%. And also we are finding that the repair cost of the shorter buildings is higher than the repair cost of the taller building as a percentage of the cost of the structure. And if you look at the recovery time, this is the new paradigm which is not there. If you just look at the y-axis, repair time, the recovery time, which is in days. So you can see that the recovery time on the x-axis is the return period of how rare the earthquake is. And if you just look at the number in the y-axis, you can see that recovery time is measured in terms of years and not in terms of hours or days or weeks. And this is the feature of the buildings which are fully complying with the code. So the impeding factors are there which significantly increase the recovery duration, But most of the buildings we are finding can be immediately reoccupied after a design basis earthquakes. If all people want to do is to go and sleep in the night, then we are finding that it can be quickly made to that level, so people don't have to stay in relief camps. But then to be able to use some function or something is not possible. So the functional recovery is found to be unacceptably long duration for all the buildings as per the design, as per the code. So what I am concluding is that the code confirming buildings, they perform satisfactorily against collapse prevention as did the intent, but there is a very high probability of losing functionality even at the design basis earthquake. And the average repair costs, they are at the design basis earthquake is less than 5%, but it shoots up drastically when you go to stronger earthquakes, which means the code level earthquake at MCE. And the mobilization time required to react to the event and then start doing the repair, they have a major influence of the reoccupancy. And the way forward, which I would like to say, is that this is just an illustration that unless we incorporate economic functionality and recovery objectives, we will not be able to move towards resilience of our designs, and we will be stuck with only life safety. So thank you all very much. This is all I wanted to share today.
Thank you, sir. We can take one question if anybody asks. Okay.
Not exactly to the resilience kind of thing. So you have used about performance-based design. So the forthcoming codes are coming up. So whether performance-based design is limited to existing structures or newly building structures also?
No, performance-based design will take at least 5 years to come in IS code, and so it would be the next major revision, and that looks at not just the structural behavior after an earthquake, but also the behavior of the internal, say the internal contents and other such things.
Yeah.
So what should be their behavior, and also give you the ability to control them. But performance-based design gives you the ability to control them, again looking at them as structural components.
Yeah.
So a lift, for example, is a cascaded structure from the main frame. So it does not look into functionality per se. So that is performance-based design, which is going to be the next generation of codes.
Yeah. Even after coming also after for a few years, it should be limited to old structures or new structures also?
New structure designed after that point.
Yeah. Okay. Thank you, sir.
Thank you. If we have more questions, we'll take after the next
Yeah,
lecture. Thank you, Professor Sinha, for that nice overview on how do we build resilient structures. So let me now introduce our next speaker, Professor 𝗗𝗲𝗃𝗿𝗁. He's a renowned expert in structural engineering and sustainable infrastructure, a distinguished expert in the field of structural and civil engineering, currently serves as the Deputy Director of the Institute of Lightweight Structures and Conceptual Design at the University of Stuttgart, Germany, and where he has held a professorship in structural engineering since 2000. His research focuses on reinforced concrete under seismic loading corrugated steel web composite bridges, bridge life cycle management systems, and the development of European bridge design standards. Professor Nowak work is widely recognized in the international engineering community through his publications, including the notable corrugated steel web bridges published by FIB, and his leadership in interdisciplinary cross-continental research initiatives, especially with countries like India and Brazil. So let me welcome Professor Nowak to the stage.
Okay. Thank you very much for the introduction. I also repeat, you should believe just 50% of what he has said. It's always the same, but no, but thanks a lot for the introduction. And now we have to change the screen. Okay. My topic is structural health monitoring towards to more sustainability, and I would like to start with, just a second. Next is this one. It's not working.
The middle one.
The middle one, dedicated to Professor 𝗘𝗴𝗃𝗏. And it's not because of the conference, it's because of my heart. I'm very proud to be able, really to be able to present my lecture, especially for you. Yeah. So, but you were talking about resilience, and others are talking about sustainability. But nobody knows what sustainability means and where it is coming from. Sustainability came from Germany. Because it's very interesting. It's no, and do you know why? It's a country with a lot of trees, and there was one man from the forestry, and he said, okay, you should not cut more trees than which can grow at the same time. And this is sustainability. But it's very difficult how to transfer to the recent time and to reinforce concrete structures, to steel structures, and to others. And so we have to be a little bit more flexible. And I've tried for existing structures to, for existing bridges, maybe to make a definition. The definition could be sustainability of existing bridges can be reached if the bridge with deficiencies can be kept for a moderate period with moderate measures to be able to find the best solution for the infrastructure. I think this would be one possibility to define sustainability somehow. And one possibility, for example, is to combine strengthening measures together with structural health monitoring. So both together, I think, we'll be able to reach best sustainability we can get for existing structures. And what I have to mention is, and this is one statement, hecticness, panic, and less decision time is the enemy of good solutions. You have to imagine, but this is the case, you have to imagine you're staying in front, with the back to a cliff 100-meter height, and somebody likes to push you, okay? And you are 10 meters away from this cliff. You should not get nervous because it's 10 meters. So you have time to think of, okay, what shall I do? If it is just 1 meter or 50 centimeters, then you can get panic, but not in other cases. So now we transferred to our bridges in our country in Germany, and if you look to the age of the bridges, you see that a lot of bridges have been built in the 70s. It is because of the Second World War, ended in 1945, and then there was the unification in 1989, 1990, and you see a lot of bridges now have an age of about 50, 55, 60, 70 years. The expected lifetime usually, we say 100 years, but up to now, I think no bridge has reached this. The modern one didn't reach up to now 100 years. So we have to think of, okay, if there's a need to replace structures, how we can manage it in a way that we have the right priority and that we have enough time to develop strategies to replace the bridge in the way that the infrastructure will be quite under operation, quite good under operation. This is very important. Here you see the different bridge load models which have been developed from the, I would say, from the early 50s till today, and those bridges are under, I would say, have a problem, and they have to be replaced in a couple of years because the infrastructure has increased in number of layers and in weight. And one big issue is fatigue, for example. Fatigue and corrosion. That means durability. And then we have to think of, okay, what to do with those bridges? When they have to be strengthened, or shall they have to be strengthened? Shall they have to be replaced, or do we have alternative methods? And to make this decision, I think it is important that we have enough time, not just to say, okay, I know how to erect a new one, simply remove the old one. In many cases, sorry for to say that, the consulting companies, especially in Germany, they say the bridge is in a bad condition, replace it, and I know how to build a new one. And I charge you just a few euros. You know, they just think on their own profit and not on the society and the needs. I think this is very important to know, because then you can handle it in a better way. The structural health monitoring as method for identifying the actual load-bearing behavior and structural reserve to gain time and to take the right decision. This is one alternative method which can be used, and we have also tried it several times, and I would like to show you some cases, and also I would like to show you a new development of structural health monitoring, which will be able to shift the structural health monitoring on a totally new level. 𝗘𝗴𝗃𝗶𝗹 you know already, because we already have discussed it in detail, but I think this is a big potential for the future. First example is a valley bridge 𝗘𝗃𝗃𝗁. This is located in Germany, in the northern part of Frankfurt. It's a multi-span girder made out of pre-stressed concrete, and if you look to the cross-section, it's a double web T-beam, in each direction one superstructure, in total a length of about 1 kilometer. Erected 1968, and there was one first strengthening which has been realized. It was 2014, and then after further investigations it has been found that this first strengthening was not sufficient, and additional one had to be performed, had to be done. And then we have been asked, okay, what can we do? The problems were we have no sufficient remaining service life due to deficiencies, especially in view to fatigue. And when you look to fatigue, then the verification itself is very, very sensitive. And we have tried to apply the actual verification method for fatigue to this bridge, and theoretically, numerically, this bridge would collapse after 5 years. But the bridge already has an age of 50 years. So the verification is not very exact. And this is a big problem, because we don't know how far we are from this cliff, what to do. We know that there are deficiencies, but we don't know exactly how large they are. What we did is we have designed a balanced cantilever, like it will be used, for example, for creep tests. That means you have, depending on the ratio of the lever arms, you have an uplift force, and depending on the weight, and this uplift force will kept constant, independent on each and everything, just dependent on the gravity. But the possibility that the gravity will change dramatically within the next years is very small. Okay? And this is what we have done. You have a very good... okay. Okay, here you see the tower and the balanced cantilever, and the main, it is not really working, which is quite, okay. This is a strategy as simple as possible and as complicated as needed, and not the other way around. And please, this is also a hint for my colleagues, for all the scientists. Make it as simple as possible and as complicated as needed. But the problem is, and the challenge is, you have to know the complicated solution to be able to make it simple. Because otherwise you're not able to verify whether the simple solution is sufficient. And it's very interesting. I've talked to so many colleagues, and then we had this solution, and I presented it, and then they said, oh, this is so simple. It's so simple. Yes, of course it's simple, but you have to know the complicated solution to be able to make it really simple. And this is, and the advantage here with this balanced cantilever, you are independent on settlements, you're independent on thermal actions, on each and everything. The uplift force is always the same. That means there is no uncertainty. But we have also to check, okay, what is with the, okay, here's the small drawing, and then we had to check, okay, what is the result of this uplift force regarding the cracks which already have been occurred, and how to be able to check the future behavior. And what we did is, first, very simple one, we just have glued LVDTs at the cracks, and then we have made a long-term monitoring to check how the LVDTs are working and how the crack widths have developed. And now I'll show you a very funny situation in the next or over next slide, where you can show what will happen if, for example, the traffic deviation will be done in a wrong way than planned. Here you see some impressions. This is the, sorry, can I go back? Here you see the LVDT on top, right hand side, the balanced cantilever. Here is the weight on the right hand side, and this tower has been planned in a modular way that it can be adjusted very easily. Okay. You need a little more space. That means, for example, in cities it might be not applicable. Then you have to find other solutions. But I will tell you which other solutions exist. Here you see the record of the LVDTs of one LVDT, and here you see the first. We have activated the support in 2 steps. Here you see the first step, and then the next one, the second one, and you see it works very well. And then after a couple of days, you know, all the data will be automatically transferred to the university, and we every day we check it, and if something is wrong, then we have to react somehow. In parallel, also a camera has been installed to check if something is strange, whether maybe the traffic is not okay. Maybe some very heavy lorry has crossed the structure and so on, to be able to react. This was the original traffic arrangement. You see the left-hand superstructure and the right-hand superstructure, and this was the original arrangement of the lanes. And what we have advised is that the lanes have to be shifted because the left-hand web was overloaded, to reduce the loads onto the left-hand web. And then this record came into our office, into the institute, and then we have thought, okay, there's something wrong, because suddenly there was an increase of crack widths. And then we thought, okay, let us check what happened. And then we have looked to our camera and onto the pictures, and what we have seen is that instead of shifting the lorries to the right-hand side, they shifted to the left-hand side. And without this monitoring, we would not have been able to identify it. That means, and you know, the admin people from the road administration, if there is no real need to come to the structure, they sit in the office and wait, you know? So what and it was Friday, I think it was Friday, and then we called them, and then we said, okay, you did the wrong deviation, and instead of reducing the loads, you have to increase the loads. So you have to act immediately, and then they got nervous and worried, and and then the deviation has been done in the right way. So this is, for example, a very nice example where you can show how strengthening methods, along with structural health monitoring, can work very efficiently and can avoid that mistakes will be done which will be not identified in a sufficient time period. That means just to make strengthening method or just to have structural health monitoring is not sufficient. You have to check it not once in a month, every day you have to check, every day or every half a day you have to check, is something wrong, and so on, to be able to react fast. Then I remember there are some situations where you cannot react because it's a sudden collapse. 1 year ago, or just 1 year ago, there was a collapse in Dresden. It's in the eastern part of Germany, and this failure was a failure without any pre-announcement. That means this was a sudden failure due to hydrogen-induced stress corrosion, and within 1 second this structure collapsed. And then you have no chance. No structural health monitoring is able to react so fast, within seconds, no chance. So you have a minimum time which is required, maybe I would say 1 hour, 2 hours, 3 hours. This is the minimum. And it would be wrong to state that within 20 minutes you are able to react, no chance. Okay, the next one is, the next example is in Hamburg. It is a bridge which also has shown some deficiencies in shear and in bending of the compression zone. And then we didn't have much space. So what we did is that we have thought, okay, let us support the midspan somehow, because we had 2-3 meter space. And what we did is we have erected and planned one D beam with some hydraulic jacks, which are shown. This is on top of these spring elements, and the hydraulic jacks will produce constant uplift forces. Usually, you make an uplift force, and then you fix the hydraulic jack. And then the problem occurs: what will happen? For example, if it gets winter, if it gets cold, if there's a settlement, and so on, then the uplift force will change. Okay, but we have to have it in a certain limit. And our idea was, and this we have realized several times, what our idea was to place spring elements coming from the railway below this hydraulic jack, which are very weak. And that means if you apply the uplift forces, the spring elements which will be constrained somehow. Okay, and that means if the superstructure will get deflected due to live loads, maybe due to settlements, the change in the uplift force will not be very dramatic, just plus minus 10%. And this depends on the stiffness and on the geometry of the springs. And then you make a simulation, and you check the boundaries, and we could show that the deviation from the predicted uplift force is about 10%. Here you see the details after erecting. Here you see the beam on the left-hand side on top. Then here you see the hydraulic jack, which has been fixed after applying the forces. And then we had to control the deformation, the constraints of the contraction of the spring elements with LVDTs. And with these LVDTs, we were also be able to identify if something strange happens with the traffic, for example. And this is shown here. This is a record of one day, and here you see two scenarios. In the middle, there was a traffic jam. This can be identified with these what is a hole, like a hole, and on the right-hand side there was a large sign from one LVDT, and this was because of a heavy truck which has crossed the structure. And this gives you also, again, the possibility to check and to monitor the bridge in a way that you are able to identify whether some strange events occurred during the day, for example. So also here, each and every day, we were monitoring and analyzing the numbers. And it's, of course, under responsibility of the engineers to be able to interpret the numbers in a good way. Is there something severe happens or not? And this is the biggest challenge, to be able to check the values in a way that you say, okay, the numbers will lead to immediately measure actions or something like this. And now we come to the development which has been done within the last, I would say, 4 years in my institute. Maybe you know these optical fibers, which will be used for telecommunication. And usually you will send a signal through, and then you hope that the full signal will go through the end. But there is some reflection. And the telecommunication companies, they won't like to have reflection, but we like the reflection as a civil engineer, because the reflection can be analyzed, and because it gives some frequency, and with analyzing the frequencies, you can produce a so-called fingerprint of this fiber, and then you are able, if a strain will occur, due to the change of the frequency, to say which change of strain has occurred. And this with an accuracy of about less than 1 millimeter, dependent on the total length of the fiber. And this has, of course, you know, this has been developed for the military first, but then there was also the idea to have it for other applications. And by luck, we had contact with the company who have sold those in Germany, and then we thought, okay, let us make some tests to check whether it's applicable for existing structures. So we have an integrator which gets all the numbers, and if strain will change due to some deteriorations, for example, a crack occurs, then this crack can immediately be identified in time and in location. That means what you do is you take this fiber and then you glue it on the surface continuously, and then you install it with the interrogator, and then you can analyze the numbers, and then you know immediately if something happens. And this you can do in real time. Real time means real time. That means just the time the SMS or the internet will need to transfer the signal to our institute. That means less than 1 minute. So, detect and localize non-visible local developments, almost full-field strain monitoring and crack detection on critical structural areas, spatial resolution within a millimeter range, depends on the length on the fiber. Real-time monitoring is possible. Real-time means real-time, not with delay of 5 hours. You can automatically monitor it. That means you have to program a special device where you can filter the signal, and then if a threshold value, for example, will be reached, then you get automatically an alarm to your mobile, for example. But at first, before you were able to use it, we had to make some laboratory tests, because we had to think of, okay, which fiber with which coating is the best one, and there are a few possibilities, and we have checked 2 different ones. This is the second one. This is the acrylic one, very thin and very sensible, and the other one is the EPR with a diameter of 2.8 millimeter. And when we made the tests, then we have seen that there are different sensitivities regarding the question, what is with the interaction between glue, outer layer of the fiber, and the fiber itself. And when you look to this, and you're familiar with crack width limitation and with bond, then you see that this is the same topic as we have it in a normal reinforcement, where we talk about the question how the load will be transferred from the reinforcement into the concrete. This is a differential equation which has to be solved just with different parameters. Just a second. Oh, it's sleeping again. Here you have the, okay, and what we checked is stiff adhesive and soft coating here, or stiff coating and elastic adhesive. And then we have made some tests to check it. And this delay will not be counted to my presentation time, please. But I'm the last speaker, isn't it? So, okay. So sometimes we have to have an advantage, you know? So, and here you see the difference. We have pre-capped the section. It's a concrete section. We have glued the fibers into this into the concrete, and then to this into this concrete, and then you see how it behaves. This is the one with the more stiff mortar, and this is with the elastic mortar. That means this was kind of acrylic, for example, and the signal is a little bit more weak here, and here it's much more precise. And this is also much more robust, this number A1, and so we have decided to use this for further investigations. But now, then we also could identify how it looks like. For example, if the bond will go, this is shown here, then the shape is a little bit different. And usually you have to make a differential equation, which have to be solved to check, what is with the crack widths dependent on the signal. And due to this very special stiffness relations, it could be linearized, which makes life much more easier, because then you just have to look to the peak signal, and then you know what the crack width, how the crack width is looking like. This is shown here. This is one for this A2 cable, and the other one is for the A1 cable. Then we made some 4-point bending tests. You see it here, we have glued on the lower surface the fibers. And then we have made a 4-point bending test. Here you see, this is the final crack width distribution, or crack distribution. 1, 2, 3, 4, 5 cracks, okay? So this is very nice to have, but this is nothing very special. The question is how sensitive the fibers are. And now I'll show you a picture where you see how the cracks have been developed. First crack, the second from the left. And if you look to the right-hand side, you'll see 2 small bubbles here and on the right-hand side. And the second one has been developed here and already identified in the first step. And then the third one has been developed right to the second one. It's here. And then the fourth one has been developed, and finally the fifth one at the end. And I have to tell you, in parallel, we have also measured crack widths with the LVDTs. The LVDTs are still, they are in a deep, deep, deep sleep, and the fibers already are getting nervous. This is a big advantage, but also a very big disadvantage, because you always have to deal with nervous fibers. And the number of the volume of data is very high. I will show it later too. That means to filter it is a challenge, but I think with the modern computer technologies and filter systems, this is not a big deal. Then we went to the field, and you know this bridge already. This is the Valedictory 𝗗𝗃𝗃. And what we did is we have to check the region of the coupling joint. And then we have checked how the crack widths will develop. Here you see, okay, we also have controlled with LVDTs, and here you see how it has been glued. Okay, and here you see the signal. This is the lowest point, that means very close to the lower surface, number 1. And then number 2 is a little bit higher, number 3 is a little bit higher. And so you can see how the crack widths have been reduced with increasing the height. That means it's a very, very nice result, and we could take it as a basis for further investigations. And here you see the other fiber, which is a little bit more weaker, and the signal is a little bit more unsharp, but also okay. And then what we did is, you know, you're some kind of, you're a prisoner of your knowledge, you know. Then we thought, okay, what we can do else with these fibers? And then there was a chance to measure the cross distribution of the structure. It's always under discussion, what is with the cross distribution if you have 3-web T-beam or so, and what is with the stiffness of the upper chord and so on. And what we did is, we have glued 5 fibers. This is an arch bridge, and this arch bridge has got an extension after a couple of years. And then there was a question, okay, how the loads will be distributed in cross direction. And then we have made a load test. And okay, here the crack width also detected. This is already known. And then we have checked how the cross direction have been developed. And you see very nicely how the cross distribution has been developed. That means it can be done as a basis to calculate the stiffness for the cross direction. Because it's always under discussion, okay, if you have the main lane on the right-hand side, what will be distributed to the left-hand side? And then finally, the final example is the river bridge in Hochheim. This is also a very interesting one. And here we also have made a lot of investigations. What we did is, this is the first application worldwide with very, very long fibers. The whole length of the structure is about, I don't know, 400, 500 meters. We erected in 65 to 67. That means, again, sensitive against hydrogen-induced stress corrosion, pre-stressed, and double-web T-beam. Okay, not sufficient durability because of stress corrosion, no more. So there's no pre-warning. That means we have here a brittle behavior, a brittle failure, and deficiency in shear resistance. Then we thought, okay, let us check the shear resistance along also with the longitudinal direction. And what we did is, here on the right-hand side, you already can see it, we have glued those fibers in a direction where it was just crossing the cracks due to shear, okay? And this was the challenge. 5 years monitoring, now about 3 years are gone. 16 fiber sensors, each 100 meter. That means in total 1.6 kilometer have been installed, and 3 monitored spans of 2 superstructures. Here you see the site. With the railway, it was a challenge because we had just a few pauses of the railway to be able to install the fibers. And here you see the arrangement. You know, cracking is just 90 degrees deviated from the orientation of the fibers. Here you see the detail. And then first the first installment, and then we have checked the numbers, and this looked very nicely. And then again we have monitored the structure, so there's also 24/7 monitoring. And for example, here there was a traffic jam, you can easily identify it with the increase of the signal, for example. And the same. Here's, for example, one situation where a crack has developed. This was here in this point 25.8. This is this one. That means at 4 a.m. in the morning, this crack has developed. And if a threshold value will be crossed, then automatically an alarm will be sent by email. Okay? That means sometimes you have to get up at 4 o'clock and you have to check, okay, whether it's serious or not. And this is one challenge, to be able to identify whether it is serious or not. And then we made some load tests. It's just to show you what we did. So we have taken a lot of chances to play with our fibers. Here you see the lorry which has been used, and this was during the night where the highway has been closed temporarily. And then here you see how the signal have developed depending on the different locations. So, and this is, I'm also very proud, the TV people, they have been very interested in this, and then there was a kind of documentation, some kind of science documentation. And then I was in the television, I was so proud, or happy, I don't know, and then you see it here. This is in German, but no problem. This is the lorry, you know, and this is glued along this beam.
Genau, und jetzt bildet sich auf der rechten Seite ein Teil, das heißt dort, stopp, dort wo sich jetzt das Fahrzeug befindet.
You see, the maximum signal is.
Und rechts und links werden aber auch noch Dehnungen aufgenommen, das heißt alle Millimeter, alle 2 Millimeter gibt es ein Signal und wir können über die Länge den Dehnungszustand.
Gianluca, you are able to understand it.
Und dann auch weiterfahren.
Yeah, very good.
So, man fährt dann schön über die Brücke, jetzt sind wir etwa in der Mitte. Man sieht in der Mitte jetzt also schön den Maximalwert, rechts und links wird es weniger, so wie es auch sein muss. Und jetzt fahren wir völlig entspannt über die gut bemessene und sichere Brücke bis zum Ende.
Sorry, I was too lazy to translate it into English, but I think you got it somehow. Okay. So now we come to the end. If you make such developments, this cannot be done just by one person. You have to have a team. And here we had the very lucky situation. We have 4 people. Myself as professor and experience for I don't know how many years, similar to, good morning, similar to him, okay, and he's still sleeping. And one PhD student of mine, one former PhD student of mine, and one who was familiar with bridge inspections. That means we have accumulated the whole knowledge. That means each and everybody could contribute somehow, so that we had a success, really success. The people were very happy, and we got a lot of projects now. I always say you could not remove one of us, because otherwise it would not have worked. And when we made the test, just one more no, short story. We made it in the cellar of our university, and there are fire alarm detectors, okay? And one of the both colleagues of mine, they cut some, I don't know, some reinforcement or some they made some grooves in the concrete, and then a lot of smoke came, and then the alarm have been released, and then automatically, because it's a university, all fire stations in Stuttgart in parallel, they started to go to the university and to check whether a severe fire has occurred or not. And 1 month later, I got the bill for it. So this is also experience which you have to get. But you have to be able, you have to do it by yourself. I think this is so important. You cannot get, as a scientist, you cannot come, do this, and then you look to the result. You have to, you have to take the hammer and then you have to hit your finger. Then you know that it hurts. This is so important. Otherwise, no chance. And also in this development, I was also involved somehow in this practical application. This is just the proof check. This is me. This is one of my co-worker. And with this smile, I would like to thank you very much for your attention. Thanks.
Thank you, Professor Nowak. That was a very interesting lecture on covering both the laboratory experiments and field test, and also at the end, like you said, you have to do it by yourself to know what you're really doing. I think that's very, very important.
I told this because now I'll tell you the next story. I never forget, it was, we are far from SASC in Chennai, okay? There was an experiment which has been undertaken in SASC Chennai. It was about retrofitting of beam column joints, okay? And they used to do it in a way, okay, there are some labors, and then they start with this ceremony, and then they hope that the experiment will go somehow, and then you will do this, you will do this, and you will do this, and you will do this. Then they turn around and left, okay? And I was staying, and I thought, why did they leave? Why did they, and the neighbors, they did something. And then I got a little bit angry, I have to say, but it was the beginning of a very, very good relation to SASC, really. And then I talked to Lakshmanan, some of you know him, he unfortunately already passed away, and then I told him, hey, this cannot be, we have to do it in a different way. Give me the plaster of Paris, give me this, give me this, give me this. And then he looked at me, yes, please. And then I've taken all the things, and it took 3 hours, and have made all the arrangement, and finally it worked. And then it was for them also, and the head of this laboratory, he started with talking to me, I'm experienced for 25 years now. And I thought, okay, fine, but you don't know how to handle it, I think. But finally we had a very, very good success with all the experiments, and very impact, and very nice publication, so it was the beginning of a wonderful story.
Thank you for sharing that experience. So we can maybe take one question, any of you have?
Just one.
Just one, because we had tea break, tea waiting.
Now then we can go to tea break also. Prakash. Make it not too complicated. I can only only give simple answers, not complicate.
Very good evening, sir. It is really pleasure hearing you. In specifically health monitoring of the bridges, when we are dealing, many times installation of the system is really a typical task, specifically the instrumentation and collating it. Is it like okay when we are doing health monitoring on continuous real-time monitoring? install the system on the structure itself with the drilling and all. So all those damages are being considered into picture, and then it's self-vibrating, and then correction factor for the particular vibration has to be considered.
This has to be checked in advance in the lab, because otherwise you have no chance. You cannot take it and then simply glue it and hope that everything's fine. It means what I've shown here in this movie, I would say, it is step by step. You have to start, I compared with textile carbon fibers, they started taking it, concrete, cast it, and then they thought, okay, let us check what happens. This is not the right way. You have to start from the beginning. You have to think, where are the weak points, where are the strong points, what do I have to investigate on, and so on and so on. And vibration is always a topic, but if the fortunate is that the fibers are so weak that vibration itself will not affect them.
Right.
But the signal is very sensitive, and I have to tell you, and also the data quantity. Each and every day in this bridge in Hochheim, we produce 300 gigabyte of raw data. That means we have to reduce it in a handleable way. Otherwise, it will be taken and then put it in the, I don't know where, in the basket, and that's it.
Thank you.
Yeah, Professor Novak, very entertaining presentation. Just a quick question. You had that scale factor, right? The CMOD, and then you've done it in the laboratory conditions, and then when you put it, the fiber optic sensors in the field, I'm sure temperature also will play a major
role. Yes, we have compensated temperature, of course. I didn't. I could not show everything because we have time. We have made the lab test. Then we have made a preliminary field test. Where we already knew what is going on, because then it is easy to check, and of course you have to compensate the temperature.
Right.
Okay.
Right. Oh, thank you.
Thank you. We'll Professor Novak, Professor 𝗘𝗏𝗃, could you please come on stage? And I request Professor Satya and Professor Mayapprasad to come on stage to felicitate them.
Ladies and gentlemen, we have come to an end to our 3-day ICCMS 2025. A very good evening, and a warm welcome to the valedictory function of this remarkable conference. As we come to the close of an enriching journey filled with learning and collaboration, this session marks a celebration of the knowledge shared, connections built, and milestones achieved. We are honored to have our esteemed dignitaries and guests with us today. I would like to invite Professor K.N. Satyanarayana, Professor Suresh Jain, Dr. Bijli Balakrishnan to the dais. I request everyone to please rise for the prayer.
𝗓𝗃𝗃𝗃 भगवतीं बुद्धिप्रदां शारदाम्.
Thank you, everybody. Please sit down. To formally begin the valedictory session, I invite our esteemed patron, Professor Suresh Jain, Head, Department of Civil and Environmental Engineering, to deliver the welcome address. Sir.
Good evening, everyone. Distinguished guests, eminent speakers, colleagues, industry partners, delegates from across the globe, and the students. It is with great pride and deep sense of fulfillment that I welcome you all to the valedictory session of the 3rd International Conference on Construction Materials and Structures, ICCMS 2025, hosted by IIT Tirupati. Over the past 3 days, this conference has evolved into vibrant ecosystem of ideas, ingenuity, and international collaborations. The central theme, synergy of materials with structures, had resonated not merely as an academic concept, but as a call for action, inviting us to reimagine structures construction in the age of climate energy urgency, urban complexity, and digital transformation. We are deeply honored by the gracious presence on contributions of our esteemed plenary speakers, keynote speakers, session chairs, the participants, the technical presenters who have really contributed immensely in this particular conference. On behalf of the organizing committee, I extend the heartfelt gratitude to all these speakers on behalf of IIT Tirupati, on behalf of the organizing committee, and on behalf of Department of Civil and Environmental Engineering. Importantly, the Young Researchers Forum and the participation from over the dozens of the countries reaffirm our collective commitment to nurturing next generation thought leadership in construction science. On behalf of organizing committee, I express our deepest gratitude to Professor K.N. Satyanarayana, the Director IIT Tirupati, whose unwavering vision transformed this endeavor into a global platform of substance and significance. I would like to place on record my sincere appreciation for Professor 𝗘𝗶𝗃𝗁 Balakrishnan, Chair of ICCM 2025, whose exemplary leadership, strategic vision, and tireless efforts have been instrumental in organizing this international conference at such an exceptional scale. Her unwavering commitment to the academic excellence and collaborative engagement has truly set a benchmark for the future endeavors. As we draw this chapter to a close, may the networks forged here continue to inspire innovations, resilience, and sustainability in the decades to come. Thank you all, and may your journey forward to impactful and inspired. Thank you, everyone.
Thank you, sir, for your kind and unwavering support. We are honored to have with us our Chief Patron, Professor K.N. Satyanarayana, Director IIT Tirupati. I now invite him to address the gathering. Sir.
So good afternoon, everyone. So you can judge the success of a conference by the audience that is there at the valedictory function, right? And when you look at the hall full at the valedictory function, you know this conference has really gone well. So I'd like to really congratulate Dr. 𝗘𝗃𝗁, and the whole team under the guidance of Professor Suresh Jain for the way they organize this, you know, as we are a new institution coming up. Of course, we are now getting to be 10 years old, getting, you know, this is the largest conference we have hosted at the institute with more than 500 delegates, close to 600 delegates participating, 10 parallel sessions running on 3 days, It's not an easy job to organize this, and she had taken this leadership in doing this, and also the way the conference is evolving from what they have started at NIT Calicut, Blesson, Scaria and others at NIT Calicut. They're the first version, second version, and this is the third version. And when we call it an international conference, good to see good international presence, right? We have our friends from various universities across the world. You had participants from 12 countries? Yeah. So yesterday, Professor Novak was telling me that he had gone to this international conference and he was the only international person at that conference. So, so a person from outside the country. So from that angle also, it is very heartening to see the strong participation that we had from our friends. And as we talked at the inaugural, bringing the materials people and the structures people on a common platform. Right? That's a very important issue that each of the groups work in their own silos very often, and getting them together to talk about the various research that's progressing, advancements, and so on. And also the kind of industry participation that we have seen with the support from the various in terms of sponsorship and also participation. Some of the leading manufacturers in our sector and the players in our sector, like our platinum sponsors, Ramco and JSW, and then the big construction players like L&T, 𝗘𝗴𝗶𝗃𝗃, right? 𝗘𝗴𝗃𝗃 happened to be our contractor also, so if you see the buildings around here, they were the people who helped us build them, and various others. Also the materials manufacturers like Sika and instrument manufacturers and all that coming over and participating. And it's most heartening to see a lot of myself being a civil engineer, and the IIT Madras colleagues, a whole bunch of them here, and their students and their grand students, right? They're all, many of them have come here because we're going to have a felicitation function later on for our senior colleague, Meher Prasad. So this network that has been created and nurtured, I know many of them came because they knew the senior professors were going to be around and they wanted to meet them. So the platform that has been created, because conferences are places where you go there to get to know what is the trends that are happening in terms of research, development, but also to network, right? I was recently reading this article by this professor, I think at Maryland or somewhere, who studies how research collaborations happen. And she said that 90% of very successful collaborations emerge from when people met at conferences, went out for a walk, went out for a beer, and or a dinner, and that's how many of these collaborations have blossomed. So in this world, in these days of online and hybrid and these platforms, I think we're missing that part of it, where people really sit down and rather than just listen to someone on the screen and then you go on. So I think it's still very much important that we meet here and create this partnerships, friendships, and collaborative networks. And conferences provide this platform. And I think from that angle, this conference has been very successful. Going forward, I understand they've already lined up where the next conference is coming. So it looks like this conference is growing in its visibility, in its impact. So, but most importantly, for IIT Tirupati, it's an opportunity to showcase what's happening here, and so that we also create our networks, strong collaborations, and so on. Nothing like coming and seeing how things are going. For those of you who have come and seen this place, what we built here, in the next 3 years, if you come back after 3 years, This campus will, in terms of, not in the case of area, in terms of buildings, will be double what you've seen here. We have got the funds tied up for the next phase of construction, next phase of equipment procurement. So you will see considerable changes that are going to be happening here. And Tirupati is also, everyone knows Tirupati as a spiritual destination, a pilgrimage center, the richest temple in the world, at least richest Hindu temple in the world. Not in terms of course, Vatican owns so much of the world, but in terms of the income that it generates and so on. So that's what it is known for, but it's also turning out to be a major educational hub. It's turning out to be the major educational hub of the state. We have about 7 universities, and in a town that is less than 400,000 people. We have been blessed that we have IIT here, we have IISER just 3 kilometers down the road. So a lot of things we are doing together, and we are lucky to also right now have a government which is very progressive on the technology front. They are firing their engines full throttle on all, starting from quantum to deep tech and all these areas, defense and so on. So with that, there's going to be a lot of things we are hoping. We are also trying to create a research park across the road, for which we got the funding tied up to start the phase A of the research park from the central, from our Ministry of Education. And then we are also working with the state government to create a very strong ecosystem. So a lot of opportunities that are coming up, and we are looking forward to take these things to take forward the growth path of this institute, and emerge also as a very soon, probably, I think we're catching up with some of the second generation IITs reasonably well, and very soon, maybe 10 years down the line, catch up with the first generation IITs also. At least that's the hope, that with 23 IITs in the country, the ecosystem is, and also the other institutions, right? IITs and the NITs and the state universities and the private universities. But once again, I will close. This is what I've been talking everywhere. How do we create civil engineering to be an exciting area? How do we look at being a structural designer or construction person to be in a sexy role, right? How do we create that buzz about our profession? I think all of us need to really introspect. And it's not only for our own survival, but from a country's perspective. As I keep repeating, we still have to build 50% of the infrastructure in the country, and all of us have to do something about it. Otherwise, I'm very worried where we're going, right? So that's a message I've been leaving wherever I go, that we really need to understand. Things are changing so fast I keep saying that we cannot be teaching civil engineering the same way we taught as I studied 40 years back, right? And my favorite, the costing of, if you take buildings, is when I studied at that time, the structure probably cost 70% of the cost. You had very little finishes, you have very little services, you had very little, networking systems, all those things. And in today's structures, in today's facilities that we create, probably structure is costing only 30 to 40% of the cost, right? A lot more is going into finishes. You look at this room, the wall paneling systems, the fall ceiling systems, the flooring systems, and the networking systems, the firefighting systems, the power systems, and then the plumbing systems that go into this building. They are costing almost, that is the first cost. But when you go to life cycle cost of 50 years, the structure cost comes down to less than 10%. Right? The biggest cost element becomes energy. So what I'm saying is, absolutely fundamentals are important. We should grill that in, but that's not enough. And with the changes that are coming around, with all the IoT and AI and all these things, there's going to be a drastic change in the next 5 to 10 years, and we should all be geared towards that. It's not business as usual. It is things that we have to look at things in a very different way. Like just now I was listening to Novak, that the thing cracked and he gets a phone call at night, right? So these are all, we have sensors which are tracking these things and transmitting the data that you need to act on it fast and all. So, right? So structures, you can't just, structures is not just designing your steel and the concrete and so on, but also tracking how it is performing. So a lot of things are happening, very exciting times, very challenging times, exciting times, and I wish we take this excitement across to a larger group of people to join us. Thank you very much. Yeah.
Thank you, sir, for your inspiring and thoughtful words. It's now time to honor excellence. We move on to the award distribution ceremony. I request Professor K.N. Satyanarayana to kindly do the honors as we felicitate the winners and contributors who made this event truly special. The award for Best Paper Oral Presentation for Theme 1 goes to Anita Nayak from IIT Dharwad. The award for Best Paper Oral Presentation for Theme 1 goes to Gokul Santosh from IIT Madras. The award for Best Paper Oral Presentation for Theme 2 goes to Srijit K. from NIT Calicut. Srijit K. From the same category, we have Sinan Abdul Ghafoor from Vimal Jyoti Engineering College, Chemperi. The award for Best Paper Oral Presentation, Theme 3, goes to Mohan Lal from CSR CBRI. The award for Best Paper Oral Presentation in Theme 3 goes to Nandana KK from NIT Calicut. Nandana K. Now, the award for Best Poster for Theme 1 goes to Prashant VP from IIT Hyderabad. Prashant VP from IIT Hyderabad. The award for Best Poster for Theme 2 goes to Satya Ishwara Sanyasi Rao Kohli from NIT Raipur. The award for Best Poster under Theme 3 goes to 𝗗𝗏𝗃𝗶 from NIT Raipur. Now we award the student volunteers that made this event a success. We'll be calling the student volunteers by committee wise. I request the chair and co-chairs of the committee to please come up and take your award. The first, organizing committee, Mr. Vishal and Mr. 𝗘𝗏𝗃𝗶𝗿𝗁. The next is Technical Committee, Chair and Co-Chair Divya S. Kurup and Anjali A. Please come up to the stage. Next we have the Logistics Committee, Mr. Rubendra D, Mr. Vijaya Raj S. Now we would like to call the Food and Catering Committee, Chair and Co-Chair 𝗘𝗏𝗃𝗶𝗿 Ahmed and Ritik Raj.
Sir, Manoj sir.
Manoj sir, please. Next we have the Hospitality Committee, Chair and Co-Chair Gagan GS and Susra Maunika. Next we have Registration Committee, Maladi Bhanu Prakash and Pushparaj Gandhi, Chair and Co-Chair. Now we have the Publicity and Media Committee, Abhilash and K. Leela Aparna Devi, Chair and Co-Chair. Next is Website and IT Committee, Mr. Arun Kumar S. and V. Naveen Kumar, Chair and Co-Chair. We have Sponsorship Committee, Mrs. Arifa, Chair. Lastly, we have the Volunteers and Help Desk Committee, and I would request the chair and co-chair of the committee to kindly come up to the stage and receive the awards for all on behalf of all volunteers. Mr. Manish Kataria and Mohammad 𝗗𝗲𝗃𝗁, chair and co-chair. Thank you. The unparalleled success of ICCMS 2025 stands as a testament to the indefatigable efforts and visionary leadership of our conference chair, Professor 𝗘𝗶𝗃𝗶𝗿 Balakrishnan. Her profound dedication, culmination in months of unwavering commitment, has been truly instrumental for this, and we extend our deepest gratitude on behalf of the Institute, department, and all the attendees. I now invite our esteemed conference chair, Professor 𝗘𝗶𝗃𝗶𝗿 Balakrishnan, to deliver the concluding remarks for ICCMS 2025, followed by vote of thanks. Ma'am.
Distinguished guests, esteemed speakers, delegates, colleagues, sponsors, and friends. As we conclude the third International Conference on Construction Materials and Structures, I am deeply honored to deliver the vote of thanks on behalf of the organizing committee and the Indian Institute of Technology, Tirupati. Over the past 3 days, we have witnessed an extraordinary convergence of knowledge and innovation, unified by the theme, Synergy of Materials and Structures. Through the insightful plenary lectures, engaging keynotes, dynamic technical sections, and spirited discussions, this conference has served as a powerful platform for examining the evolving challenges and exciting opportunities in our field. As the construction industry seeks innovative solutions to meet the environmental and performance goals, ICCMS 2025 has demonstrated how research can effectively bridge the gap between theory and the real-world application. With 31 plenaries and keynote sections, over 400 peer-reviewed presentations and posters, sponsors-led showcases, international participations, ICCMS 2025 affirmed its role as a true global and inclusive forum for knowledge exchange. The diversity and the depth of topics from carbon-negative concrete life cycle assessment to digital fabrication and adaptive systems reflected both the maturity and momentum of our discipline. We are proud to have hosted participants from over a dozen countries, making ICCMS 2025 a truly international event. Your presence has enriched the discourse and set the stage for the future collaboration. We deeply value your contribution and engagement. Chairing this conference has been one of the most meaningful, joyful of my professional life. It has been both an honor and deeply humbling experience. The mentorship from my senior colleagues, the unwavering support of peers, and the inspiring energy of our students have left a lasting impression on me. The journey has not only shaped me professionally, but also personally. I would like to extend my sincere thanks to our academic and technical collaborations, Virginia Tech University, Queen's University Belfast, Monash University, IIT Bombay, NIT Calicut. Our technical partners, ICI, RILEM, and our publication partners who have amplified the impact of this conference. We are truly grateful to our eminent plenary and inviter speakers, Professor Mike Clegg, Professor Ravindra Gattu, Professor Manu Sandhanam, Professor Martin, Professor Venkatesh Kodur, Professor Balthazar Novak, Professor Narayana Naidalas, Mr. Rajiv Goyal, Professor Ravi Sinha, Professor K. Sendilnar, Professor K.V.L. Subramaniam, Professor Surya Prakash, Professor Radhakrishna-Pillai, and many others, for sharing your invaluable insight. Your contributions have significantly enriched the dialogue and will inspire future research and practice across the globe. To all the authors and presenters, especially your young scholars, thank you for your dedication. intellectual rigor, and passion. Your work embodies the very spirit of this conference, innovation and impact. I also extend heartfelt appreciation to our sectional chairs, review committee and the technical program committee for shaping a high value and high quality coordination technical program. This event would not have been possible without the generous support of our sponsors. Platinum sponsors JSW, Ramco Industries, Ramco Siemens, thank you for your unwavering support. Golden sponsors Sika, L&D Constructions, Asian Paints, 𝗘𝗶𝗃𝗏 and Electro Steel. Your timely support greatly enhanced the delegate experience. Silver sponsors, our 11 silver sponsors, your thoughtful contribution supported the key logistical and operational effort. To all our industrial collaboration, institutional partners and individual well-wishers, thank you for your continued encouragement and commitment to academic advancement. My deepest thanks to Indian Institute of Technology Tirupati, especially Department of Civil and Environmental Engineering, for the institutional support. The state-of-the-art facility at the lecture hall complex, exceptional hospitality and seamless coordination across the department created the perfect environment for the global event. Special thanks to administrative staff, engineering unit and the computer center technical teams, housekeeping and security teams. Your professionalism and tireless work behind the scene ensured everything ran smoothly. I extend my deepest thanks to our Chief Patron, Professor 𝗘𝗴𝗃𝗏𝗃, Director IIT Tirupati. His inspiring presence and continued guidance have been a source of strength and clarity. Personally, I am grateful for his mentorship and the trust he has placed in me. It has played a profound role in shaping my journey. To Professor Suresh Jain, our patron, head of the department, thank you for your unconditional support, mentorship and encouragement. Your guidance has been both selfless and transformative. To our 19 student steering committee members, 56 student volunteers, your commitment, your energy, professionalism have been truly remarkable. While we had planned to recognize a best volunteer, we found every one of you were exceptional in your own area. We are proud of your work and hope this experience has been meaningful for you as it has been for us. To my professors and mentors, Professor Pradeep Sarkar, Professor Devdas Menon, Professor Meher Prasad, Professor Radhakrishna and many others, thank you for shaping my journey with your wisdom and belief in me. To my family, loved ones and friends, your constant love, patience and quiet strength. We are proud to have hosted participants from over a dozen countries, making ICCMS 2025 a truly international event. Your presence has enriched the discourse and set the stage for the future collaboration. We deeply value your contribution and engagement. As we close this chapter, let us not only carry forward the knowledge exchange here, but also the new friendship, the shared vision, and the collaborative spirit as defined by ICCMS 2025. The synergy we have spoken about is not just academic, it reflects a deeper call for collective responsibility in shaping a more resilient, sustainable, and equitable built environment. On behalf of organizing committee, thank you all for being a part of this journey. Many connections forged here blossom into impactful research, transformative innovations, and enduring partnership. Wishing each of you continued success and a safe travel back home. Thank you very much. I would be honored to call Dr. Blessings Career to the stage to hand over the baton for the next conference, ICCMS 2027.
Good afternoon, everyone. Very happy to see that ICCMS 2025 is a very grand success. The conference we started in 2021, continued in 2022 at IIT Calicut, and for the third ICCMS, when I approached Dr. Bijli to host it at IIT Tirupati, she took the challenge and
this conference is, they have proven that this conference, it became a grand success. So I am thankful to everyone, especially Dr. Bijli, Dr. Suresh Jain, Professor Satyanarayana for his very exemplary leadership. And I'm very happy to announce the next ICCMS 4 to be held at IIT Bombay, and Dr. 𝗘𝗴𝗶𝗃𝗵 will be hosting the ICCMS 2020 ICCMS 4. I request Dr. Bijli to hand over the baton to Dr. 𝗘𝗴𝗶𝗃𝗵. It's really heartening to see the young faculty taking the lead in organizing these events, starting from the Calicut team here and then at IIT Bombay. Good tidings.
Thank you, everyone. So thank you, Professor Bijli, Professor Satya, Professor Jain, and also the entire team of ICCMS 3rd edition to having, for doing such a wonderful conference. I think Bijli had an easy option of always showing the temple town card, and she get a lot of participation here in Tirupati. Well, I also have a great card of Bombay. The only problem would be to keep the audience inside the hall. There is so much more happening outside the campus. So I'll be very happy if you can come to IIT Bombay and participate in the 4th International Conference of Materials and Structures. Thank you so much.
We are pleased to announce the award winners of conference will be getting Rylum free membership. One free membership for 1 year. As we conclude, I request everyone to please rise for the national anthem.
पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे.
Thank you. With that, we bring this valedictory session to a close. Wishing you all continued success and safe journeys ahead. Jai Hind.